The operation of FET, field effect transistor. Hello, welcome to D Creations Resources. We have been talking about N-channel JFET, N-channel junction field effect transistor. We have seen its construction and now we are moving towards understanding its operation. So let's first talk about an important aspect of depletion region. Now consider an N-channel JFET. So there will be P-type gate and N-type channel, which is going to constitute the PN junction. Now this PN junction is always reverse biased in JFET operation. And in fact, due to this reverse bias, the input impedance of FET is very high. The reverse bias is applied by a voltage. You can call it say VGG. And this voltage is connected between the gate and source terminals. Now, if you will recall reverse biased diode, you will remember that whenever a PN junction is reverse biased, the electrons and holes diffuse across the junction and leave behind the positive ions on N side and negative ions on P side. The region containing these immobile ions is called the depletion region. As the reverse bias voltage across the junction is increased, thickness of the depletion region also increases. If both the P side and N side of the junction are equally doped, the depletion region will extend equally in both the regions. However, if one side of the junction is heavily doped as compared to the other side, the depletion region will extend more into the region of lower doping. Now, this phenomenon is important in case of FET, this asymmetry of the depletion region. So, in JFET, N-channel JFET, since P region is heavily doped as compared to the N-channel, the depletion region extends less into the P region and deeper into the N-channel. Incidentally, when there is no applied voltage between the gate and the source, the depletion region is symmetrical around the junction. The conductivity of depletion region is 0 because there are no mobile charge carriers in this region. Hence, the effective width of the N-channel is reduced. It further reduces with the increased reverse bias voltage applied across the gate and source terminals of the JFET. The reverse bias across the gate source junction of a JFET can also be achieved by applying a voltage across the drain and source terminals. It may be noted that the drain is connected to the positive terminal of the DC supply and source is connected to the negative terminal. So basically, when we want to talk about operation of JFET, we need to keep in mind that the depletion region is not symmetrical around the gate to source junction. It is extended more deeper into the channel near the drain terminal and less on the source terminal. Now let us look at the operation of JFET. When a voltage is applied between the drain and source with a DC supply voltage, you can call it say VDD, the electrons flow from source to drain through the narrow channel existing between the depletion regions. This constitutes the drain current ID and its conventional direction is usually from drain to source. The value of drain current is maximum when no external voltage is applied between the gate and source. So the voltage can be denoted as VGS is equal to 0. And this particular current is usually designated by the symbol IDSS. The reverse bias voltage across the gate source junction is then increased. As a result of this, the depletion regions are widened. This reduces the effective width of the channel and therefore controls the flow of drain current through the channel. When the gate to source voltage is increased further, a stage is reached at which two depletion regions almost touch each other, or in other words, we can say the channel is pinched off and the drain current is reduced. Now, at a certain voltage, this channel will be completely blocked or pinched off when the depletion regions completely touch each other, and that situation you're going to have the current as 0. The gate to source voltage at which the drain current is 0 or completely cut off is called the pinch off voltage. Now it is designated by the symbol Vp. The value of pinch off voltage is negative for n-channel JFET because we are basically talking about reverse bias, and it's going to depend on doping of the N and P regions of the device and also on the width of the original channel structure. Now let us consider the characteristics of JFET in the next video.